We're on lesson 33 today, and if you will, please read pages 176 over to 177, but take into close consideration what it says in bold black print. The degree of a polynomial is the value of the greatest exponent. Okay, so in the case they give you f of x equal x to the 15th plus 19x to the 12th minus pi x to the 5th, the largest one is 15, so it's a degree of 15. So the end behavior of a polynomial can be determined by looking at only the largest degreed term. So in that case, we'd look at x to the 15th. If x is a really, really big positive number, then y would be a really, really big positive number as well. If x was a really, really big negative number, then y would be a really, really big negative number as well. So we look at the highest degreed term to determine the end behavior for a polynomial. The next thing is irreducible quadratic factors never cause a polynomial to equal 0. So the one they give you as an example of is g of x is equal to x squared plus 4. If you set that equal to 0, you get x squared equals negative 4. Well, there is nowhere that x squared is equal to negative 4, so that's why it will never give you a 0. That's a quadratic factor, an irreducible quadratic factor. All right, next thing at the bottom of the page, the graph of a polynomial crosses the x-axis when a linear factor occurs an odd number of times, and it touches but does not cross the x-axis when a real linear factor occurs an even number of times. So if it's an odd number of times, like to the first power, to the third, to the fifth, and so on, then it's going to cross the x-axis. That would be what we've been doing. If the factor is there an even number of times, for example, something like x minus 2 raised to the second power, or x minus 2 raised to the fourth power, then it's going to touch the x-axis and turn around and go back. Okay? All right, so keep that in mind. If you look on page 177, we have f of x is equal to x plus 4 to the first power, x plus 2 to the fourth power, x squared plus 3 times x minus 5 to the third power times x minus 7 squared. It says, at what values of x does the graph of f touch the x-axis, and at what values of x does it cross the x-axis? All right, so let's do cross and touch. So remember, cross is the odd number of powers. So 1, 3, 5, and so on and so on. So it's going to cross at the x plus 4, but remember, we have to set each one equal to 0, so x plus 4 equals 0, so it's going to cross at negative 4. Okay, and this is an irreducible quadratic factor, so it's not going to do either, is it? Here's another odd power to the third power, so this will give us positive 5. All right. Then where it touches, it's the even powers. So that would be the 4 and the 2. So x plus 2 to the fourth means it's going to touch at negative 2. X minus 7 to the second means it's going to touch at positive 7. All right. The next one, 33.2, it says, which of the following graphs most resembles the graph of y equals x minus 1 squared times x plus 2 quantity squared? Okay, well, in the first place, the total degree of this polynomial would be, that's an x squared times an x squared. So we're looking at x to the fourth, aren't we? So our end behavior would be determined by x to the fourth. So when x is really, 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 really big positive, then y is going to be really, really big positive, so it's going to come from this direction. Okay, our zeros are at 1, and I'm just going to label this 1, and at -2. Okay, now this is an even numbered power, so it's going to touch it and do what? It's going to touch it and go back up, right? And we can easily plug in 0 for x. So this would be 0 minus 1 and 0 plus 2. So that's -1 squared is 1. And 2 squared is 4. So this is at 1, 2, 3, 4. So it's going to go like this. And then it's got to come back down here to -2. But what's it going to do at -2? That's another even powered. So it's just going to touch and go back up. And if x is a really, really big negative number raised to the fourth power, it's going to be a really, really big positive number, isn't it? So, which one of those graphs looks like that? Okay, it's not A, because it's going the wrong direction on the right. Same reason it can't be B. So we're looking at C or D, and I obviously didn't get this exactly right, but it does cross at 4. We found that out over here. What I didn't get right on my sketch is that it keeps going up and then it comes down. So, which one is it? C? No. Because it's coming down at 4 and it's still going up at 4. If we plug in like -1/2, we'll see that it's going to be higher up here. And then, so it can't be letter C, it must be letter D. So in those cases, you want to look at the end behavior. We knew that both ends had to be going up, right? So that ruled out A and B. And then we knew that, oh, I wasn't even looking at the zeros. D has the touch at 1 and -2. C has it at the opposite points. So there's why it had to be D. All right, then. On page 178, let's see. Oops. Which of the following functions is most likely to produce this graph? Okay, so it looks like this. Like that. And now bold black print up at the top of page 178. The turning point theorem tells us that the graph of a polynomial function has fewer turning points than the degree of the polynomial. Well, let's see how many turning points we have. We're going down and we're going up. That's 1. We're going up, we're going down. That's 2. We're going down, we're going up. That's 3. We're going up, we're going down. That's 4. Okay, so 4 turning points. All right. And it says that it has to have fewer turning points than the degree, which means that the very minimum, it has to be an x to the 5th, doesn't it? Okay, well, all 3 of those are larger than that. So now let's look at the end behavior. If x is a really, really big number going this direction, y is a really, really big negative number. Okay, so if x is positive and it's x to the 7th, then the big number would be positive, right? So that one can't work. Minus x to the 6th, if x is positive, it would be negative. That works on this end, okay? And same with negative x to the 5th. If x is a really big positive number, this would give us a really big negative number. Both of those work so far. Let's go to the other end and look at it over here. If x is a really, really big negative number, and you raise it to the 6th power, then this would be positive times the negative means it would still be negative, wouldn't it? All right, if x is a really, really big negative number raised to the 5th power, this would be negative times the negative would make it positive. That's what this is a big positive number. So it can't be this one. So that means it has to be the h of x is equal to minus x to the 5th plus 10x to the 4th minus 35x cubed plus 50x squared minus 24x. All right, the only thing we have to look at is the lead term. That's what determines the end behavior. And we knew about the turning points, but any one of those equations would have worked because we have 4 turning points. And those degrees are all higher than 4, so we were fine on any of them. All right, so always remember, concentrate on the end behavior of your graph. There are several examples to look at over on page 179. I encourage you to look at those. Let's see. Down at the very bottom of page 179, this is super important and it's really hard to pick out of here. But the x value of the inflection point is given as minus b over 3a. Looks similar to what we would have used out of the quadratic formula for the discriminant, but this is the point. This gives you the x value of the point of inflection. Now, point of inflection is a point where the graph changes from going up to going down. Changes from concave up to concave down, which will cover concavity later on. But this you need to remember, okay? X equals negative b over 3a. That's the x value of a point of inflection. All right. This one says sketch the graph of y equals minus x cubed plus 3x squared minus 2x plus 3. Okay, it's a cubic. There's nothing that's going to factor that's going to help us find a 0 or anything else. So we're going to use this formula right here. Minus b over 3a. Okay, well, if we use that, we get minus b. This is a, b, c, d, so on and so on. So minus b, that would be minus 3 over 3 times a is negative 1. Negative 3 over negative 3 is positive 1. So that's the x value of the point of inflection. If we plug in 1 to this equation to get the y that goes with it, it's going to be 1 comma, then y would be equal to negative 1 cubed plus 3 times 1 minus 2 times 1 plus 3. What does that equal? 2 minus 2 is 0, 3. So we know that at 1 comma 3 there's a point of inflection. All right, now let's look at the end behavior. If x is a really big positive number, going this direction, this is a negative x cubed. So this will be a really big negative number, so it's going to be going down like this on this end. On this end over here, if x is a really, really big negative number, then x cubed would be negative times the negative makes it positive. So it's going up on the left and it's going right, down on the right. Okay. We can also find where it crosses the y-axis by plugging in 0. That would be 0, 0, 0, 3. So we also know that it goes through the point 0, 3, right? Okay, so let's see what that would look like. What it could look like. So we know the point of inflection was at 1, 1, 2, 3. We know that graph is there. We know that it's going down on this direction, and it's going up this direction. So, I mean, there's several different things. It's an x cubed, so it can't have more than 2 turning points. But because we know that it crosses at 3, it's got to do something. We're coming from here and going up. We got to get back to 3 because we know it crosses at that 3. So even though it could be like this, it's not very reasonable because somehow it's got to be the same y value at those two different x's. So again, these are sketches, but do what you can to make them as accurate as possible. Okay, so I'm putting this on Saturday evening. You should be able to watch this video on Sunday and have this assignment to submit on Monday. We will have a Zoom session on Monday, and I will give you instructions on how we're going to take the test on Tuesday. I'm going to go ahead and put lesson 34 in the video also. I want you to watch that tomorrow as well and have both assignments ready to turn in on Monday. Okay, thank you guys.